Hello everyone, welcome to my channel. In my last video, we discussed vector embedding and vector database. Today our topic is RAG. I will start with the basic concept of RAG. Then I will demonstrate a small project of RAG. The project is implemented using Spring AI and PGVector. RAG stands for Retrieval Augmented Generation. I will explain each of the terms later. First of all, let's try to understand why do we need RAG? What's the purpose? Suppose we ask our LLM a question about a domain on which it was not initially trained. Maybe it is related to our confidential business domain data. LLM may hallucinate in such situation. If it had not been trained with the relevant information, it will end up producing some incorrect answers. There are few solution options here. One option is to fine-tune or retrain the LLM. But this is not a good option because retraining LLM is time-consuming and expensive. The worst part is we need to keep retraining the LLM whenever there will be any update in the domain data. The alternative option is to use RAG. In RAG, we retrieve the relevant contextual data from a mutable and domain-specific knowledge base. The contextual data is then added or augmented with prompt. Finally, LLM will generate the response using the enhanced prompt. Now let's come back to the abbreviation of RAG. R is for retrieval. It means retrieve the relevant data from knowledge base. A is for augmented. It means add the retrieved data along with prompt. And G is for generation. It means generate the response using LLM. Let's compare the two processes, one without RAG and one with RAG. Without RAG, LLM is just trying to produce a response using its trained data. With RAG, we'll first retrieve the relevant context from the knowledge base and then pass it to the LLM with the prompt. LLM will produce an accurate answer in this case. This is the high-level overview of RAG. Now let's dig into some technical details. For the retrieval part, we use a vector database. If you are not familiar with vector databases, I would highly recommend you to watch my previous video where you will get a very good conceptual overview on vector databases. So we'll store our domain data into a vector database. Our domain data can consist of various data sources like large PDF file or image file or audio file or video files. The first step would be to split the large domain data into smaller chunks. There can be different chunking strategies based on the business domain that we are working with. For example, for legal documents, one chunking strategy can work well. For medical documents, another chunking strategy can work better. Then each chunk should be converted into vector embedding using some embedding model. If you have already watched my previous video, you should have a good understanding about vector embeddings. So these vector embeddings should be stored in some vector database. This process is called ingestion phase. The whole RAG workflow will look like this now. The user's query or prompt will be converted into vector embedding using some embedding model. Using that vector embedding, we'll do a semantic search against the vector database that we already populated in the ingestion phase. The result of the query will be our contextual data here. Then we'll pass the prompt and the contextual data to LLM to generate the response or answer. Now let me demonstrate a small project of RAG developed by Spring AI and PGVector as the vector database. This is a regular Spring Boot project. The Spring Boot version is 3.5.5 and Java version is 21. And as the LLM, we'll use the Open AI Spring Boot starter, and we need a document reader for this project. So we have added Spring AI PDF document editor, and we will use PGVector as the vector database. So we have added this Spring AI PGVector store as the dependency. This part is the data source configuration, and this is the configuration for OpenAI. So we'll need one API key for OpenAI. And as chat model, we have used GPT-4. And as embedding model, we have used text embedding ADA 002. For vector store, we have used one configuration, initialize schema as true, so that the vector store table is created automatically. First of all, we need to populate our knowledge base. As the source of data, we'll be using the PDF version of two classical books, Alice and Alice Adventures in Wonderland and The Adventures of Tom Sawyer. So we need to split these files into chunks, convert the chunks into vector embeddings, and then store them in the PGVector database. The vector store generator class will be used for the data ingestion phase. The resource classes have been used to refer to the PDF files. We have created the instance of page PDF document reader using the file location of PDF files. And we have created instance of text splitter, which splits the document. Instance of vector store will load the chunk into the vector database. Since there are two files, we have done the steps twice. So this will act as the data ingestion phase. We are using Postgres PGVector as the vector database. We can explore the vector database using some ID like dbeaver. I have already created an empty database, books. Let's run the application now. So the application is running, and from the log, we have understood that the embedding generation is skipped now. But the vector store table is still created. If we refresh it, you can see that the table has been created. Now let's update the configuration and run again. So we will not skip embedding generation anymore. So if we see the log, we'll understand that the text splitter is working. It is creating the chunks. Okay, so it will take some time. Let's wait a bit. We can switch to, yeah, I think it has done. So now we'll switch the view to database. Now let's try to refresh the table and then load again. You can see that the embeddings has been generated now. So this is the content, this is the metadata, and this is the actual vector embedding. To use LLM, we have created one simple REST controller, and we have used a Spring AI chat client here, and it has inbuilt support for RAG. So the builder of this chat client will take one instance of question answer advisor, and in the constructor of question answer advisor, we have passed one instance of vector store. So the vector store, it will enable the context to be retrieved from the vector store using a similarity search. And so by using this chat client, so it works like a Fluent API style, and will pass one prompt here, and it will return us a response content. So let's run the application again and do some test using Postman. We have generated vector embedding of two books in our vector database. Let's ask a few questions related to those books. So one prompt can be based on the provided book Adventures of Tom Sawyer. What is the name of Aunt of Tom Sawyer. So it is populating the answer. So we have got the answer. And the another prompt can be like this. Like based on the provided book, Alice Adventures in Wonderland, where did Alice's journey begin? So it will take some time to populate the answer. Yeah, we have got the answer, some elaborated answer. And another prompt can be like this. So based on the provided book, Adventures of Tom Sawyer, where did Tom Sawyer live? So let's wait for the answer. Yeah, it has gives some kind of tricky answer here that it cannot answer the question. That's pretty much it for today. Thanks for watching. Hopefully, I will prepare another video about some interesting topic soon. Until then, bye.